In this section, we extend the concept of double integration given in the previous section to non-rectangular regions, more general regions. We begin with defining regular regions. So, if your region is regular X region and regular Y region, easily you can integrate the two variable function on the given region. Otherwise, you should try to write your region by dividing the sub-regions X regular and Y regular, okay? So actually, because of this aim, we should define the X regular region, regular X region and regular Y region. Okay, a region R in the XY plane is a regular X region, if there exist functions f of x and g of x and numbers a and b, such that we define the region as the following way, which is consist of the x and y, such that y between g of x and f of x and x change between a and b. So what is the geometry of this region? Y change between the g of x. So let's sketch the graph of the g of x. Okay, for example, this is y equals g of x, and that is y equals f of x graph. So x change from a to b. This is a, this is b. So while exchanging from a to b, y change from gx to hx, so gx to fx. So this is our region. Okay, for example, for this value of the ax, this is our y values. This is our y values for the another values of the x. So this region is our region R. This is x regular region because y depends on x and x is the regular exchange between some regular values a and b. And we can define the y regular region. So a region R in the xy plane is a regular y region if there exists function h of y and k of y and numbers c and d, such that the region R consists of the point x and y, such that x change between h of y and the k of y and y change between c and d. So the figure out of this region, x equals h of y graph like this one, for example, x equals h of y, x equals k of y graph like this one, x equals k of y. So y change between c and d. This is the c value, small one. This is the d value, big one. So our region is this region. Okay, so this region is the R. So if you can describe your integral domain as a regular x region or regular y region, easily you can write your double integral as a iterative integral, okay, like the rectangular case. So in light of the x regular region and the y regular region, we can give the definition of the double integral. So if R is the x regular region, for first of all, g of x, y, f of x, and x change between a and b, okay, this double integral for the capital F of xy function or small f of xy function, does not matter, equals y depends on the x. So you first of all you have to integrate this function in terms of the y, and by calculating the differences from g of x to f of x, you should find the interior integral. I mean this one. First of all, you should calculate this integral. Then, by integrating, obtain the result, which is a function of the x. So, from a to b with respect to x, you can find the answer of this integral. Okay. On the other hand, if your region R is a regular y region, you should use the following formula. First, you should calculate in terms of the x from h of y to q of y. So this is a function of the y. So by integrating this obtained integral from c to d with respect to dy, you can calculate this double integral. For the questions, the region described by the words. For example, let's look the following example. And from this description with the sentences, the region described with the sentences. So from this description, you should be able to write your region x regular or y regular region. Sometimes both of them are possible. Sometimes just one of the case are possible. Okay, so let's look the following example. The region R is bounded by the graph of y equals square root of the x and y equals 1 over 2 times x. Okay, so we should find this bounded region. This is our region. So evaluate double integral our function on the given region. Our function is 4x y cube dA. Sometimes we can write dx dy, does not matter. Okay, instead of the dA, it can be written in this form. dy dx or dx dy. Dx dy. But that means in this two case, you should write your iterative integral. You should write the first dy integral and dx integral. By deciding the limit of the integrand, you should calculate this double integral. Okay, so let's evaluate this integral by using the different ways, two different ways. So first of all, you should sketch your region. So what is y equals square root of the x function graph? Y equals square root of the x function graph like this one. Y equals 1 over 2x graph like that one. Okay, let's use different color like this one. Y equals 1 over 2x. So easily you can find the intersection of these 2 points. One of them is the origin, that's right. The other of them is this point. So let's calculate the intersection. 1 over 2x equals square root of the x. By taking the Actually, you can take the square of the both sides if you want, or okay, let's take the square of the both sides. 1 over 2x square equals x. So this implies x is 0 or x equals 4. Isn't it? Yes, 4 square 16. Yes, that's right. So this intersection point is 4. So now we should interpret this region as a regular x region and regular y region. Okay. So first of all, let's write the regular x region. So how x change? X change from 0 to 4. So while x changing from 0 to 4, how y change? By using vertical lines, you can decide. Y change from the red line to the black curve. 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 I mean, for example, x equals 1 value. X change between 1 over 2 to 1, for example. Okay. If you want, you can calculate these values. For x equals 4, this is 2, for example. So always a y change from 1 over 2x to the square root of the x. Okay, so a y change from 1 over 2x to the square root of the x. So the point x and y which satisfies these two conditions is our region. Okay, so this is the regular x region. And also we can describe our region by keeping the y is fixed. For example, here, okay, let's use different color. Okay, y change from 0 to 2. Okay, so while y changing from 0 to 2, how x change, let's discuss. So x change by considering the horizontal lines, x change from the black curve to the red line, black curve to the red line, black curve to the red line, black curve to the red line. Okay, for example, for these values of the y, x change between these values to these values. Okay, so what is the black curve? Black curve is x equals y square. So x change from y square to, from here, x equals 2y. So x change from y square to 2y. So this sets to describe the same region as a regular y region. So by using these two descriptions for the region R, we can calculate easily this double integral. So for the x regular region, regular x region, double integral on the region R. Okay, on the region R. 4xy cubed dA equals from how x change, let's look, from 0 to 4 and y change from here. Okay, so x change from 0 to 4, y change from 1 over 2x square root of the x, 4xy cubed. First we integrate in terms of the y, then we should integrate in terms of x. So by this way, you can calculate. This is very easy to calculation. By considering x is constant, we integrate in terms of the y. So 4xy to power 4 over 4. Y change from 1 over 2x and y change to the square root of the x. So we will obtain the function of the x. Actually here 4's cancelled. So x is constant. Instead of the y, we should write first square root of the x to power 4 minus, instead of the y, we write 1 over 2x to power 4. dx. So let's make our arrangement. X times x square minus 1 over 2 x to power 4 dx. So we should calculate this integral. X cubed minus 1 over 2 x to power 5 dx from 0 to 4. So x to power 4 over 4 minus 1 over 2 x to power 6 over 6 and x change from 0 to 4. So this is 4 to power 4 over 4 minus 1 over 12 4 to power 6. For x equals 0, this is 0. As a result, this value is 64 over 3. Okay, you can calculate. If you use the regular x region, I will not evaluate in this record, but I will write the integral. Regular y region. So double integral on the region are 4xy cubed dA equals how y change? Y change from 0 to 2, x change from y square to 2y, okay? So from 0 to 2, this is in terms of the y, integral from, I forgot, y square to y. From y square to y, 4xy cube dx. First of all, you should integrate in terms of the x. Then, by calculating difference, actually this is 4x square over 2y cube. And x change from y square to 2y dy. So you can calculate this term. This is a function of the y. Okay. So by integrating that one in terms of the y, you can calculate your value. And after all this calculation, you will find the same value, which is 64 over 3. So by this way, you can calculate your double integral. Of course, for the more general region, we can discuss the volume of the some solid. This is the same idea. Another point of the more general region is to change the order. The reason why we need to change the order is sometimes you cannot integrate in terms of the x first, then integrate in terms of the y. So because of this reason, you may need the change of the order, okay? So how you can change the order? By deciding your region. I will solve some example in the problem solving hour, but let's briefly mention about this situation in this lecture records of the integration. So for example, we have this double integral on the region 4xy cubed dA. Okay, actually this is our example, the previous example. So what we know that this region from 0 to 4, this is the one of the integral x over 2 square root of the x 4xy cubed dx dy dx, sorry. Okay, so from this right hand side equation, you can describe your region easily. Actually we know here, but here you can easily describe y change from x over 2 to square root of the x, and x change from 0 to 4. So by sketching the region, y change from x over 2, this is the x over 2 graph, y equals x over 2, to the square root of the x, like this one, y equals square root of the x, and x change from 0 to 4. But I don't know where is the 4. But from the previous question, you know 4 is the intersection point, so 4 is this point. So x change between 0 and 4. So from this graph, you can describe, you can rewrite your region. It is possible here. Sometimes it is not possible, but here it is possible. So what is this point? For x equals 4, x over 2 is 2, and square root of x is also 2. So this point is 2. So y change from 0 to 2. So equals from 0 to 2. And while y changing from 0 to 2, how x change we should decide? X change from the parabola to the line, from parabola to line, parabola to the line, but we should write x in terms of the y, which is y square. We should write x in terms of the y, which is 2y. So x change from y square to the 2y. So these two integrals are the same. In the problem solving hour, I will solve another kind of the question. So by sketching region, you can change the order of the integration for double integral in more general region.